Recording. All right, so good afternoon once again. I hope you have watched all the preceding videos and you are well up to date with all of the concepts taught so far. So let's delve right into it. Continuation. We are doing probability and probability distribution. So I think we covered this example one in the last class. And I did say that when you have questions like this, it's very important to note that the probability of event A and B is the probability of A given B multiplied by the probability of B. We did this, we looked at how you could be asked to find either of these three concepts. So please, if you haven't watched the preceding video, please go get that done. All right, so we are moving on. Additive rule of probability. I think I explained this. Okay, A or B. So when you are looking at the additive rule of probability, all simply means what? You are to add up the probabilities. Okay, so for more clarity, let's just look at an example. Okay, let's just look at an example for more clarity. So we have example two here. Example two here. Can we have somebody read for us, please? Example number two. A volunteer, please.
The probability that exchange rates will be devalued next year is 0.6. The probability that there will be a rise in inflation if exchange rate is devalued is 0.4. What is the probability that either exchange rates will be devalued or there will be an increase in the level of inflation?
Okay. So I think this all here will make me go back to something here. All right, so what is the probability that that either exchange rate will be devalued or there will be an increase in the level of inflation? All right, so based on what we have learned before, we can see some concepts here. The probability that exchange rate will be devalued next year is 0.6. Okay. The probability that there will be a rise in inflation if exchange rate is devalued. So based on this, this is the condition. This now will be this 0.6 will be our probability of B, the condition that has to be set in place. All right, so what is the probability of A then? Probability of A if B is put in place. Probability of A if B is put in place is 0.4 here. But before we go further, I was talking about the OR concept here. So when you have OR introduced in this situation, what do we need to do? Look here, probability of A or B, when one of them is a condition that the other is based on. What do we do in such cases? Probability of A plus the probability of B minus the probability of A, B. All right, so let me just see this place quickly. The additive rule. The additive rule is used to determine the probability that at least one of two events will occur. For example, given two events A and B, the additional rule can be used to determine the probability that either A or B will occur. If the events are not mutually exclusive, that is, they can exist simultaneously, double counting must be avoided by subtracting the joint probability that both A and B will occur from the sums of unconditional probabilities. So I think this Venn diagram explains this further. So this is the probability of A. This is probability of B. Now, if they are not mutually exclusive events, that is, if they are independent events, double counting must be avoided by taking away this shaded part where they overlap or intersect. So when you have such, probability of A or B will be the probability of A plus the probability of B minus the probability of A and B. We talked about or and the one of our previous classes. So bearing that in mind, let's look at this question we have here now. So we have established what here is the probability of A. Probability of A is the probability that there will be a rise in inflation. How am I tagging it A? Because I was told that if exchange rate is the value, so this is the condition. So that's because of that, I say my probability of A is 0.4. Now, what is the probability of B? Probability of B, if exchange rate is devalued, that's the condition. So I come back here, the probability that exchange rate is devalued is 0.6. So again, this is probably that there will be a rise in inflation. Let me call this inflation so we don't mix it up. Then this is what? Exchange rate devaluation. Probability of B, we know is what? 0.6. Now, the question asks, what is the probability that either the exchange rate will be devalued, probability of exchange rate devalued, or there will be an increase in the level of inflation. So what does that tell you? It can be expressed as probability of B or A. I could also write it as a probability of A or B. Now, either way I write it, what does this tell us? When you have probability of A or B, the formula says that you should go the probability of A plus the probability of B, then take away the probability of the intersection A, B. So first, we know the probability of A, 0.4, we know the probability of B, but we do not know the probability of AB. Probability of AB. So when you hear
Please, sir.
probability of, okay,
Please, I have a question.
go ahead.
How do you know that in this particular scenario, both situations are mutually and not mutually exclusive? How were you able to tell?
That's a good question. All right, so we go over it again. The probability that exchange rate will be devalued next year is 0.6. The probability that there will be a rise in inflation if exchange rate is devalued is this. Okay, so men looking at it, it is they are independent in events because exchange rate does not, whatever happens with the exchange rate does not necessarily have to affect inflation. They are two independent events. Are you with me? One does not hinder the other. From your knowledge of economics, I think this is a given. I don't know if I've answered your question.
All right, sir.
Okay, so now that we have this sorted out, what is the probability of A and B? So the probability of
Question,
A and
please, sir.
B,
Question, sir.
okay,
Yeah, so why did you not use 0.6 as your probability of A?
good question,
Since
good
that's
question.
like the
I,
first
I try to,
statement.
good, I try to emphasize that here. Maybe you missed it. So let's go over it again. Your question is, why didn't I use 0.6 as A, right?
Yes.
Good.
Since
So
that's
look,
like the
just
first statement and then, yeah.
so just flow along with me as I read this and it will become clear to you. The probability that exchange rate will be devalued next year is 0.6. This is settled. We don't know what it is, A or B, we don't know. But look at the second sentence. The probability that there will be a rise in inflation, if exchange rate is devalued, is 0.4. If exchange rate is devalued is 0.4. What does that tell us? That the probability that there will be a rise in inflation is dependent on something. What is it dependent on? If exchange rate is devalued. Are you getting it now?
Yes. Yeah.
Good. So because of this, if exchange rate is devalued, that gives us a clue that this exchange rate devaluation will be our B. Then this will be the A. I hope that settles your question.
Yes, yes, sir.
All right, so now I'm trying to get the probability of A and B. So probability of A and B, like I told you the other time, is to simply multiply them both. So when you do 0.4 times 0.6, please input that in your calculator quickly and tell me what do you get? I'm waiting.
0.24.
0.24. So what is the probability of A or B? Bearing in mind that B is the condition on which A came about, and that led us to use into this formula. So it goes probability of A 0.4, probability of B 0.6, minus probability of A and B, the intersection 0.24. So when we do this is 1 minus this, it should be 0.776. Are we together, guys? 0.76 or 0.72? Okay, so I guess this is where the error came about.
0.76.
Yeah, so this is where the error came about. The CIS manual 0.4 times 0.6, they wrote it as 0.18. I'm not sure this is not the right answer. I hope it's clear to everyone. Feedback. I hope it's clear.
Yes, sir.
All right, so we are moving on. Dependent and independent events. I don't like all these stories. I just love moving to the questions, but let's see. Two events are said to be independent if and only if probability of A given B is equal to probability of A. Equivalently, probability of B when A is given is equal to B. Okay, so when two events are not independent, they are dependent. The probability of the occurrence of one is related to the occurrence of the other. If you are trying to forecast one event, information about a dependent may be useful, but information about an independent event will not be useful. When two events are independent, the joint probability of A and B equals the probability of their individual probabilities. Um, Okay, so therefore, if you're interested in two independent events with probabilities of this and this respectively, probability that both will occur is probability of first independent event multiplied by the second gives us this multiplicative rule, blah, blah, blah. Anyway, I guess example number 3 should help us further here. Can we have somebody read this for us, please? Hello?
As part of your work as a banking industry analyst, you build models for forecasting earnings per share for banks recover. Today, you are studying Zenith Bank. The historical record shows that 55% of recent years, Zenith Bank's equity per share, earnings per share has increased sequentially, and in 45% of recent years, earnings per share has remained unchanged sequentially. At this point in your analysis, you are assuming that changes in sequential earnings per share are independent. Earnings per share for 2009 were larger than earnings per share for 2008. What is the probability that earnings per share for 2010 will be larger than that of 2009? A positive change in sequential earnings per share. What is the probability that earnings per share decreases or remains unchanged the next 2 years?
Okay, so when we have a question such as this, first you need to come back here to better understand this concept, starting from here. When two events are independent, the joint probability of A and B equals the product of their individual probabilities. So, probability of first event multiplied by the probability of second event. And this has been already established. You multiply them. Now, it goes further to say we are interested in two independent events with probabilities of 0.75 and 0.5. Probability that both will occur, that is A and B, will be what? The probability of A and means times probability of B. So this is the multiplicative rule we are talking about. So the probability of the multiplicative rule for independent events generalizes to more than just two events. So if you have A, B, C, their probability will be probability of A multiplied by B multiplied by C. I hope this is clear to us. Can I get a feedback?
So can you go by it one more time?
Okay, so what I'm just simply saying is that what is the probability of independent event simply means you multiply each event, the probability of each event by the other. Remember we said in the last class, yellow, green, and blue balls, probability of yellow and blue. I told you to pick probability of the yellow balls, maybe 4/10, and probability of the green balls, maybe 3/10. All right, so this will give you 12/100. You break it down further. 12/100, yes. So this would be 4 here, 3, 4 here, 25, 3/25. And simply means multiplying. Let's just establish that. So you are told further that two events, one has a probability of 0.75, the other has a probability of 0.5. Probability of both events occurring, multiply them, the same principle being taught. So when there are three events now, A, B, C, the probability of the three events will be probability of A times probability of B times probability of C. I hope that is established now.
Yes.
Okay, so now we come to the question. As part of your work as a banking industry analyst, you build models for forecasting earnings per share of banks recover. Today you are studying Zenith. The historical record shows that 55% of recent years, the EPS has increased sequentially. All right, in 55% of recent years. Then, in 45% of recent years, the EPS has remained unchanged sequentially. At this point in your analysis, you are assuming that changes in sequential EPS are independent. That is established. EPS for 2009 were larger than EPS for 2008. So what is the probability that EPS for 2010 will be larger than EPS for 2009, a positive change in sequential EPS? What would that be? Can somebody has had a guess for this, please? What's the probability that EPS for 2010 will be larger? Go into the question and see what clue that would give you. What is the probability that EPS for 2010 will be larger than EPS for 2009? Who wants to give this a try? Read through the question, the answer should jump right at you there. Anybody? Come on, you guys can do this now. Just read the question. The answer is right there. This one does not even require any calculation.
1/2.
I didn't get that. Please come again.
55%.
Beautiful. It's 55% and not 1/2 because this is it right here. The historical record shows that 55% of recent years, Zenith Bank EPS has increased sequentially. So what is the probability that EPS for 2010 will be larger than EPS for 2009? Straightforward, 0.55 or 55%. All right, so let me ask again. What's the probability that EPS for 2010 will be lower than EPS for 2009? Anybody?
5%.
I didn't hear you.
45%. That's 100 minus 55.
The good one. That will be lower or remain stagnant. Is that what we have here? And in 45% of recent years, EPS has remained unchanged. Okay, so maybe that's what we were giving. Negative and remained unchanged. We can group that together. All right, so let's go on. So I guess this is settled now. The first question we said is what? 0.55%. Now look at the second question. What is the probability? Please, I need you to understand the second question, please. What is the probability that EPS decreases or remains unchanged? In the what? Somebody help me. In the what?
Sorry, is it 0.55% or 55% and 0.55?
My bad. Sorry about that. 55% or 0.55? Are we clear now?
Yes, thank you.
All right, thank you for spotting that. Now, what's the probability that EPS decreases or remains unchanged in the next 2 years? So, what's the probability of EPS decreasing? Anybody?
45%.
45%.
45%. Oh, is there space here? Or remains unchanged? What's the probability of EPS remaining unchanged?
45%.
45%.
45%.
All right. In the next 2 years. In the next 2 years. Now, go back. So what do we do at this point? Anybody? For can I get okay, I already displayed the answer already.
But the rule says, or are we not supposed to add it like 45% plus 45%?
Good one. That's a good one. But this is where it gets, I think that is what we should do actually. And when we do that, what should we get? Let's go with that first and see what that leads us to. Get it done. I'm waiting.
$0.9.
0.9. Now, there's something I want you all to pay particular attention to here now. All right? Look at this question. Where is it again? What is the probability that EPS decreases or remains unchanged in the next 2 years? In the next 2 years. So we are looking at 2 years sequentially. I will go with 0.9. No, I don't know. But why in the wait? Hold on, please. Okay. I think I've gotten it now. So please flow along with me. Let's take 2 years now. the next 2 years. What do we have here? Which year are we looking at? So 2010, 2009. Let me go with 09, then 10, 11. Oh, this is 12, please. Please note this. So this is 12. So we want to see the probability that EPS decreases or remains unchanged in the next 2 years. Are you with me? So for it to, we want to look at 2 years at a go. So what would that be? Decreases and remains constant because we want to consider 2 years at a go. So for us to look at 2 years at a go, we are taking the probability of a decrease and the probability of it remaining constant because now we are considering 2 years at a go. I think this is the key factor we are considering here. All right. I don't know if that makes sense, please.
I didn't really get it.
Okay. So we want to look at the probability of the EPS remaining constant and decreasing or remaining constant. You know, the question said or, right? But we're not looking at it, we're looking at it rather within a 2-year frame. So for me to look at it within a 2-year frame, we'll be taking them both together. All right. So that's why I'm looking at probability of EPS decrease, which is 0.45, and probability of EPS remaining constant, which is 0.45. Both of them has to go together. All right. So that's what I'm thinking. What about this here? Okay. But you know what we'll do? Let's keep this for now. Let me mark this and skip this. I'll return to this later. Okay. Let's move on to the total probability rule. Are you with me, please?
Yes, sir.
All right. So for the total probability rule again, just stick by the formulas, plug in the values, and you should be fine to go. So when we say total probability, first, if you remember your set theory, who can tell me what this means? If this is your universal set, numbers from 1 to 10, and A is a subset of your universal set, and the elements of A are your even numbers. What is A complement?
Every
Who can tell me
other
what?
every other data that is not in A.
Beautiful. Every other data that is not in A. All right, so let's bear that in mind. The total probability rule can be applied in many scenarios. The rule is stated thus. Probability of A is the probability of A and S, which was further broken down from what we have learned previously to be the probability of A when S is given. S here is now replacing our B from what we have been learning previously. I hope you are not lost from here. From all these portions here. Where is it? From here. From here. So you are replacing this B by S. That's what we are having down here now. I hope I still have my audience, please.
Yeah, it is, sir.
Okay, so probability of A for what is it called? Total probability rule now goes thus. Probability of A and S plus the probability of A given the complement of S. So what is the probability of AS? Is probability of A when S is given multiplied by the probability of S plus the same principle applies here. You could have represented this S complement by any other letter, but let's just stick to this for clarity. The same principle. So probability of A given the complement of S multiplied by the complement of S. The same thing we did here for S. Here you are doing for S complement. All right. So we could have as many and so on and so forth. But for clarity purposes, let's just move into a question. Let's have somebody read example number 4 for us. Who is reading example 4 for us?
Given conditional probabilities, probability A/S bracket equals to 0.4 and probability A/S complement equals to 0.25. And the scenarios probability of S and scenario probability of S complement components then are
Complement.
0.8 complement are 0.8 and 0.2 respectively. Calculate the probability of event A.
So the complement bit has been explained here. Are we clear? If the examiners wanted to make it more difficult, they'll just give you probability of S alone. All right? You should be able to deduce the probability of S complement by yourself. I hope that is settled. 1 minus this. So, we know that the probability of event A is given by this formula. But we need to break this further down into what? Probability of A given S multiplied by the probability of S plus probability of A given S complement multiplied by the probability of S complement. Please, are we clear up until this point? Please, I need to get answers, please, before we proceed. Talk to me, guys.
Again, sir, please.
Again, let me go to the very beginning. Is this it? Okay, let me just explain this here so that. Hold on, please. So look at this. For your total probability, okay, it is given by the formula probability of A and S plus the probability of A and S complement. That is what the formula gives us. Are we clear on that? Hello, are we clear on
Yes,
that?
sir. Yes, sir.
All right. Now, what is the probability of A and S? What is the probability of what? A and S. Remember, it's probability of A and S we want to look for. Assume this S is B. Are you with me? Assume this S is B. What is the probability of AB? So I come here. Where is that B from the very get-go? Probability of A and B. This should be from two classes away. From two classes away. Probability of A and B, when we were doing change of subject of formula, we were able to manipulate this and make A and B stand alone to give us what? Probability of AB becomes probability of A given B, don't mind this one, but multiplied by the probability of B. This is what we have been able to establish from the very beginning. Where was it? Aha, this is it here. Please watch previous videos. They are really very important because these are the concepts we build on. All right, so this could have been AS here. All right, so probability of AS is the probability of A given S multiplied by the probability of S. Please, is this clear now? Just this bit. Hello.
Yes, I'm clear.
Now, if this is the probability of A given S, based on what we have here, we said it's the probability of probability of AS rather is the probability of A given S multiplied by the probability of S. What will be the probability of AS complement? S complement is just like a variable on its own as well. It's the same thing. That will give you probability of A given S complement multiplied by the probability of S complement. Does this make sense to us now?
Yes, sir.
This would have been AY. Don't mind the two letters. All right. It's just like this S. Just be putting the S complement every other place you have it here. All right. So again, when you have the probability of A and B, it is the probability of A when B is established multiplied by the probability of B. From there, you have been able to get these two values that we put here. It is these two values that are being utilized in the question we are considering now. Total probability. Where is it again? This is it. So we're told that the total probability is probability of A and S plus the probability of A and S complement. Now let's break down probability of A and S. Probability of A and S, on what we just learned up there, is the probability of S given probability of A given S multiplied by the probability of S plus the same principle here, probability of A given S complement multiplied by the probability of S complement. Is it clear up until this point?
Yes, I'm clear.
How about every other person in the class? Can somebody just confirm that then? Or who doesn't understand should talk? Anybody that still don't understand, please speak up, because when we begin to put numbers now, if you don't understand this algebra, then it will become even more difficult. So that's why I need to be clear that this is sorted in now. Are you good to go, please? Talk to me, guys. Hey, nobody is talking. Probability of A and B is the probability of A given B multiplied by the probability of B. This B could change to S. Every other thing changes. It could change to Y. Every other place here change. If it becomes S complement, it changes as well. I think I've overflogged this enough, so let's move on. So now that we have that, example number 4. Is that somebody read this already, right? Have you read this question? Example
Yes,
number
somebody
4.
has read. Somebody has.
Okay. So now that we are at this point that this is clear, look into your example number 4 and pick out the numerical values of each of these components, slot it in, and that is all. So we go again. Given conditional probabilities, probability of A given S is 0.4. See it here, 0.4. All right. Then moving on, and the probability of A given the complement of S is 0.25. A given the complement of S, I know that is over here, 0.25. All right, moving forward. And the scenarios, probability of S and the probability of S complement. S is 0.8. It comes in chronological order. Or how is it said? Good, 0.8, and over here is 0.2. And notice I've told you that they might just give you one, so you must be able to deduce the other. Now, at this point, you have been able to impute all of the individual components into the formula. 0.4 times 0.8 will give you what?
0.32.
0.32.
Please, sir, you said it might give us one, then we must use the other. What sense,
Yes.
please?
Sorry?
I didn't get what you mean by that.
You could have been told that the scenario of probability of S is 0.8, and they stop there. They're silent on this bit. Do you get it now?
I still do not understand. Sorry, I still do not.
So, if in a bag you have blue and yellow balls, and I told you that there are 10 balls in all, and somebody said he had counted, there are 7 blue balls. How many yellow balls are there?
3,
Or how many yellow balls are there? Yes,
3.
3. You know how you got your yellow
Yeah,
balls. That is
10
a
minus
whole
7.
minus 7. If in
Yes,
a class, let's say boys and girls, there are 65, the ratio, boys are 65%. What is the percentage for girls in the class?
20, 35.
35. You know how you got that, right?
Yeah,
So I am
yes.
saying that the probability of S could have been given to you as 0.8, and then the probability of S complement, they will be silent on it. So what do you think that would be?
1 minus probability of S.
1 minus probability of S given here, and that will give you 0.2. I hope that is clear now.
Yes, sir. Thank you.
You're
Very well.
welcome. So over here, 0.25 times 0.2 gives us what?
0.05.
0.05. Put it together. What do we get?
0.37.
0.37. Good. Please be mindful of your order when you want to add. I know it's been long we left secondary school, but some of us make mistakes. This is 0.32. Your decimal should be aligned. When you are adding up, this gives you 7, 3, and 0. Please take note of this. So I guess that explains total probability here. All right, so we have quite a lot of theory notes to read here. Okay, so let's just move into example number 5 here. Oh, great. I love this example. Example number 5. All right. I'm trying to save time because all of these things you would read them up on your own anyway. But then I don't want us spending time on it because that is not where the course of the matter lies. All right. So we have example number 5 here. Let's have somebody read this for us, please.
Assume that an analyst writes a report on a company and based on the research, assigns the following probabilities to the next year's sales. What is the expected value of sales for next year?
Good. Now, when you are giving probabilities, you need to be mindful of this. Okay. Probabilities are a special kind of frequencies, but then they have been done for you. Are you with me? So when you have probabilities, what you need to do simply is to multiply the probability by the values you have. Are you still following? Multiply the probabilities by what? The values you have. The sum of which should land you at your answers. I'm going to do this in 2 ways. Okay, so let's go. So quickly, I'm going to be writing. I need you to input this into your calculator. So we go 0.1 times 16 billion plus 0.3 times 15 billion. I hope somebody is inputting this into the calculator. 0.3 times 14 billion plus another 0.3 times 13 billion. Input this and tell me what your final answer is quickly. Are you almost done?
$14.2.
14.2 billion. That's our expected sales. All right, 14.2 billion. So that's how it works. Now, that leads us to a bit different concept, which is the expected variance and standard deviation. Okay, so when we have this expected variance and standard deviation, then we need to come back in here and address this like we do when all those ones we used to do like this. X, then X minus arithmetic mean of X. Then we go on in order to get your variance and standard deviation. Then we need to actually prepare the table in order to get those 2 terms for the expected variance and standard deviation. So we have the formula here. Okay, so let's look at example number 5 says, please read for us, please.
In our previous example on making a sales forecast, we found out that the expected value was 14.2 billion naira. Calculating the expected variance starts by computing the deviations from the expected value. then squaring and multiplying by the respective probabilities.
Good. So the expected value here is the same as our arithmetic mean. All right. Used in this term as expected value based on the probabilities. So now what I want you to do, because we're going to be doing this together, you're going to be doing the bulk of the work. Get yourself your rough sheet and your calculator handy. Then we go as usual. So we still have this table. Please let's start doing that right away. Let's do it together. I want you to get your hands dirty. You have this table scenario. You can leave this out if you want to. You have your probabilities. Probability here is serving as your frequency. I think I mentioned that earlier. And then you have your sales. Your sales value is your X values now. All right. So let's have this on our table. We want to do something like this. Okay. So again, we want to get our arithmetic mean. You know, when you have X, you need to get your X bar. All right. So what is our arithmetic mean? To get your arithmetic mean, you need to sum up your, ideally, the formula for arithmetic mean is what? Summation fx over summation f. Okay? So we have done that. That's the last line we did now. We just want to go over this again so you know how it works. So what's the summation of our fx? When you multiplied all of these, okay, this is this by this by this, it gave you 14.2. All right. What's the sum of our probabilities? What does this add up to, somebody? What does this add up to? 1. So invariably, we see ends up with our expected value, which is our arithmetic mean of 14.2. Are we settled with that? Okay, so our arithmetic mean set 14.2. Now, after this x here, you need to draw your x minus x bar column. X minus x bar column after this sales bit. Let's do that in our rough sheet quickly. I can't see what you are doing, but please get your hands dirty so that you get used to it. And you're using your calculator as well. So we go x minus x bar, 16 minus 14.2. What does that give you?
0.8.
So you begin to write that in all the way. 1.8. You know, for this one to put it there. Let me know when you're done. Are we done?
Yes, sir.
Okay, so now that we are done with that, remember we are trying to get our variance and standard deviation. So we have done x minus expected value of x, or the arithmetic mean. So we need to find the square. We need to find the square. So can we do that? 1.8 squared, what does that give you? That would be another column. X minus x bar squared. 1.8 squared, what does that give you, please?
3.24.
3.24. Okay, so do the others. Be mindful of negative values if you have any further down the line. Let me know when you're done. Are you done?
Done, sir.
Okay, so call your values for me. 0.324.
0.64.
Okay.
0.044.
0.04 and 1 point what?
44.
Okay, so now that we have that, now because we are giving probabilities, you need to multiply those probabilities by the square of the deviations we just did. So you go probabilities P into x minus x bar squared. All right? So let's go. 0.1 times all those
Please, I have a
values.
question.
I'm listening.
Why are we multiplying probability by the
Good
square?
question. We are doing so because we were given probabilities in the question, not frequency. Remember I told you how if it had been frequency, we would have multiplied this way. There will be
Yes.
probabilities. There's a way it works. All you just need to do is to multiply the probability by what you have here. Please take note of that. Okay? It's more or less the same thing, but I don't want to go deep into breaking it down for you compared to the other method. All right,
Yes.
Pierre, just flow along with me for now.
So you said
Any
if
other
it was
question?
frequency, it would have been what? F times X. Is that what you're saying?
Come again, please.
You made a statement now. I just wanted you to say it again. You said if it were to be frequency, it would do it in a particular way.
Yes, are you up to speed with? Have you watched all of the previous videos?
Yes, but I just needed you to, I need you to just make that statement again. That's why.
The point is, I just need to be clear on something, okay, so that you are on the same page. All right. What I'm trying to say is that if you had watched the previous videos, okay, you see that when we were calculating for variance and standard deviation, there was a process we used in getting. Can I go back? Hmm.
So do you mean the summation of the X minus X bar raised to power 2?
This is gonna take me a while. That's why. Anyway, let me just see what I can do. Mhm. Me, I'm lost too. Oh, uh, you know what? Please just note that I said that with probabilities, you multiply the probabilities by the square of the deviation. Are you with me?
Okay, sir.
Just note that for now. You can put an asterisk on that because when you go back and watch the videos, you better understand what it is I am referring to now. All right? So let's just leave it there for now, please. Uh, okay, it's like we are here, right? Okay, so please, have you multiplied the probabilities by the square from the deviations?
Anita.
Okay.
Done, sir.
All right, so call your values for me.
0.324,
Okay.
0.192, 0.012, 0.432.
Are we good? Yes, we are. Now, Again, when you are giving probabilities, please take note of this and you can do your research afterwards. The way we get our variance now will be expressed thus. Variance, when given probability, is the sum of what you have done here. Are you with me?
Yes.
Then, how do you get your standard deviation? What do you do
Root
to
of
variance to get your standard deviation? Anybody?
You
Square root.
square it.
You find
root
it.
of
You
Square
find
variance.
the
root.
square
Square
root.
root. Square
You
root.
find the
Sorry.
square root to get your standard deviation. So can we do that quickly?
The summation, the variance is 0.96. That's the summation of what we just did.
0. What?
96.
0.96 is our variance. Then what is this standard deviation?
0.9797.
0.9797. Or we can just say 0.98, right?
Yes, sir.
Okay. So me looking at that, that was exactly what was done here all the way. Okay, all the way. So, any questions on that, please? No question. So, I think I should just address this variance thing when giving probability and when probability is not given. So, when you are giving a question to find variance and standard deviation, let's go back to, let's just take hypothetical examples. 1, 2, 3, 4, 5. Find the variance and standard deviation of, I'm just cooking up these questions. So let's go 10, 20, 30, 40, 50. How do you go about finding the variance and standard deviation of this? Let me hear from you guys.
Let's compute the mean. We need to get the arithmetic mean first.
Okay, so what is the arithmetic mean?
150/5, that's it.
150. We all know how we got the 150 over 5 rather. 30. Okay, so when this is sorted, what do we do?
Then we'll now look for x minus x mean. X minus the mean.
X minus X bar. So this gives you what?
Minus 20, minus 10, 0, 10, 20.
20.
Then what do I do going forward?
Square.
Square.
Square the deviations, right? And this gives you what?
100, 100, 0, 100, 100.
Then what do I do at this point?
Then that's all is for variance. Get the summation.
Good. You need to get the summation. All right. So what's the summation? 800, 1,000, 1,000. All right. So what is the formula for variance?
Summation of x minus bar of x squared.
All squared.
Over n minus 1.
Over either n or this same thing, depending on what you are looking for. Are you with me? This is population. This is sample.
Yeah.
Are we clear on this, please?
Yes.
Now, this formula you are seeing here is the same, give or take, with this, more or less, when you are giving probabilities. That's just the point.
Which of the two formulas?
Look at the formulas here.
It's the same with
What you have here for variance. But you use this when your question contains probabilities. That's my point. Are we clear, please? When you don't have probabilities, stick to the original formula. But once probability comes in, please use this. Are we following? Are you with me, guys?
Yes, sir. Okay.
All right, please note that. So I guess we are done with this and this. Okay, you can get your variance here and get your standard deviation. So I think we can move on to something else now. What says the time? 2:40. Portfolio variance. I think it's getting a bit. I'm thinking we should call it a day now and continue next week. Or what do you think? Let me hear from you guys.
Please, let's call it a day. We've not had any break since we started
Wow.
in morning.
Wow, it's all right. So let's call it a day. Please, I want to beg of you again. Please get yourself up to speed with the previous videos because we are building on already taught concepts. All right, so we call it a day here. We continue from here in the next class. Thank you. Madam Rachel, are you here?
I think she's here.